Hi roboticist, we're going to continue our series in point cloud library tutorial, and in the last video we have seen how to install a 3D camera, in particular a Kinetic camera, and process the data of type point cloud. And the scope of this video is to start to understand how to process this data in order to retrieve information that will be useful for our robotic application. So for example, this is the representation in point cloud of our scene. This is just a photo, a frame that the Kinetic camera detects, and as you can see, the scene is represented by points with six coordinates. That is going to be 3 in X, Y, and Z, and other 3 that gives us the data in red, green, and blue. And so basically that's it. So if we want to have a look on what is the type of the file that you are gonna process, the data is gonna be here. So this image here has more than 480,000 points, and every point has this is represented by these coordinates. So this is gonna be these points is X, this is Y, this is Z. I remember you related to the frame of the camera, and this is the coordinate that represent the RGB data. Okay, so what we can do now? So for example, imagine that we are in industrial application and we wanted to pick this object, this cylinder one. Okay, so the objective here is to process this point cloud library in order to detect, for example, the center of this cylinder, okay, and the position related to the base link of the robot, so in such a way that we will be able to ask the robot to reach this position in order to pick and put somewhere else. Okay, so this is the objective. So if you see this image, first, before to dive into the programming of this application, let's think first what we can do. So what will be a smart approach? So first, what we will need to do is to create some kind of filter or let's say downsampling all the points, because well, we had as we said 480,000 points, and the sum of these in clustering, I will say, is gives us this solid representation that we can see from our eyes. But do we really need all these information? Well, for our purpose, not, because we just need to know that somewhere here there's gonna be something, an object that has a shape of a cylinder, and I don't want to process all these red point here. So one approach will be to downsample using a filter and represent this environment with less points. And this is called downsampling, and we're gonna use the Voxel filter. And this is the first things. And then the second thing is to, for example, recognize that here there's gonna be a plan. So we're gonna use some geometry segmentation of the plane and subtract this plane because we don't need it. And then we are going to try to fit this object into a geometry segmentation like a cylinder, but we're gonna see in a while. Okay, so as I said, let's do it by step. So first, let's code a downsampling voxel filter, and we are gonna see how this point cloud data is going to be modified using that filter. Okay, so first of all, let's create a point cloud library tutorial package, the one that will be available on YouTube. And for this tutorial, gonna provide the link in the description down below, especially with the GitHub repository, as always. So let's create a package. So catkin create package. We can call it point cloud library underscore YouTube tutorial. And then let's put the dependencies. For sure, we're gonna have standard messages. Then we're gonna code this in ROS in C++, so we will need the package ROS C++. Then we will need the sensor messages. Then PCL ROS, and then PCL conversions. Okay, so I'm opening the package that we have just created, and the first things that I'm gonna do is to create a new C++ file, and I can call it voxel.c++. And again, the scope of this code is to get the image coming from the camera that is subscribing a topic of type point cloud 2, and then downsampling all the points that we want to process. Okay, these are the package that the dependencies that we need to include. And so let's give to this code some structure. Okay, here we go. This is the int section where, as always, we need to initialize our node that we have called the point cloud downsampling, then node handle, and then here the key things. We are gonna create a subscriber that is subscribing to the topic input. And this topic input is of type sensor message point cloud 2, and in this way we are gonna tell from the terminal what will be the topic that this subscriber will subscribe into. We're gonna see in a while. And then we are going to create a publisher, because we will publish to another topic that we are going to call it output, a message of type sensor message point cloud 2. So in such a way that we can see by viewing through RVs this topic what will be the image that will be processed. So the key of this code will be inside this this cloud callback function that we are about to code. Okay, so here we go. This is the structure. So we have created a global variable of type ros publisher, pub. Okay, and now we're gonna code, as I told you, the callback function. So this callback function is going to process a variable named cloud messages that is of type point cloud 2, and well, it's gonna be a constant pointer. So let's do it. So first of all, what we need to do is to instantiate the container for the original image and the one that will be filtered with the downsampling. So here we go. We have created this cloud, which is the point cloud image that the camera is streaming, and then we have created a cloud filter, the one that will be filtered after the downsampling. So the point here is what we need to do is something similar that we have done in OpenCV with computer vision bridge. So in the OpenCV, if you remember, we need to use the CVU bridge function in order to translate a topic or a message of type sensor message into a topic that into a message that OpenCV can actually process. And in the same way, what we need to do is to convert a message of type sensor message in a message that the point cloud library actually can process. So to do that, what we need to do is to convert from sensor message to point cloud data type. Here we are. So we are passing the message that we get from the callback function in the new variable that we have set up here. So from now on, we are going to deal with a message that the library, point cloud library, can process. So now we are ready to perform the filtering. So here we go. We have created a variable of type voxel grid, and then we have set up the cloud that we are passing to the subscriber, and then this is very important, the ellipse size. So this is a parameter that is gonna tell you how fine you are gonna want to filter the data. So the higher this is, the less fine is. So the less pointer you're gonna have, and this is some kind of filtering in downsampling the data from the X, Y, and Z. And here I comment how to play, because of course this is a trade-off, because if this is going to be too high, then you are downsampling too much, and then you are not recognize what is going to be the object, what is the shape that is going to have. So then we are going to see in a while how the filter point cloud data change by changing this parameter. And the result is gonna be the filter cloud filtered. Okay, and then since that we want to check from ROS visualization what is the output of this downsampling, we need to convert again from point cloud to sensor message in order to pass that information to the publisher, so that data is going to published on the topic output. Here we go. We have instantiated a variable of type sensor message point cloud 2. Then we had to convert the data from a point cloud of voxel grid type to a variable that can be processed by the sensor message class. And then this output we asked to the publisher to publish it. So that's all, and let's compile this package, and then we are gonna run our simulation, and we are gonna see in ROS visualization if we are gonna see this topic output, and check what is gonna be the entity of this downsampling. Okay, let's run our application. Okay, so now what we can do is to run our node to downsample um, the data that the point cloud is processing. So we run the voxel executable file, and as input of the topic that the subscriber is subscribing to is going to be RGBD camera depth point. So this is the topic that this camera is subscribing to. Okay, so now the node is going to be processed. And what we can do to check what the camera is seeing right now, we could add a point cloud to, and as the topic name, we should see the topic output, which is this one. Let's check topic. Here we go, output. Let's select. So as you can see, if you remember from the last video, this is how to downsample the image of point cloud, and we can say to voxelize your image. And you can see here that the leaf size is going to be 0.1. And what this application does is to cluster somehow, and in a certain area, the image from point cloud, and make an average of the surrounding points that is around this. So that's it. As you can see here, this red points is represented from the cylinder here. And we can see here that this selection of leaf sites is going to be too coarse. And if we want to deal with something, we don't know from the points here what will be the object, the shape of it. And we barely see from these points here in dark blue that is represented from the cube here. So this is one thing, and I will say that I'm not satisfied with this. And if we want to have a finer application, so you will need to play with these leaf sites, as I told you. So we should, for example, downsample here again. And it should be finer. Let's build the package and test it again. Let's do it again, and let's first run the voxel node, but this time with the leaf size lower. So we should expect here that the downsampling will be less, and we should be able to check to see better the environments. So let's check what is the topic name output here. And now you can see that we can see better what the environment is gonna be. We can recognize better the table. We can recognize that here in red there's gonna be some kind of object, and here in the blue as well. So yeah,
So then you can check how this point is going to be changed if the environment is changing. So for example, we asked the robot to go in the upper position and then plane, and you can see that the point here is going to change accordingly. Here you are. So the robot has reached the position. We can check from the gazebo here. And so this is what the camera is actually seeing after downsampling the point cloud 2 data that is subscribing to the Kinetic camera. So the point here is that we know how to voxelize your environments, and the key factor that you need to play is this one, because I remember it's going to be a trade-off. The higher this leaf size is, less points you're going to have, so the process will be faster, but the drawback is that you risk to do not sense the environment properly, you don't know where the table is, you cannot distinguish it with the object of interest. And then if you set up lower, then it's going to be finer. You're going to have more points because they have less distance between each other, but at least you can see what is going to be your environment. You can distinguish the object, the table, the substrate, and so on and so forth. Okay, that's all for today. I hope that you enjoy this video. If you like this video, make sure to subscribe to the channel, hit the notification bell, and don't miss the next topic. And I remember you that if you want to deal with this application and being a robotic software engineer, check out the link in the description down below for the applying at the pre-selling phase of the master program. Again, thanks for your attention, and as always, keep learning robotics with Ross.